Welcome. My name is Gaurav Saxena. I work for a leading automotive company in US, and I'm going to talk about how do we use our observability for internal developer platform. Before I go there, the general thing about automotive industry is that it is moving towards software-defined vehicles. So if you have a Tesla or the cars that are recently built, you know that the expectations have gone up. You want your vehicle to perform better every day. That's the OTA deployments. On top of retail pieces, there's a tremendous amount in fleet that is around getting diagnostics and a prognosis of a vehicle. And there is a projection by Forrester saying that by 2032, there will be 100 million of vehicles connected to the cloud platform. And the revenue pool for subscription is grow 30% year over year. So how do you handle this experience for your drivers? I'm going to a little bit talk about IDP first, and then talk about some of the open source C and CF tooling along this presentation, specifically around cross-plane. There's a spec called Open Application Model. There's implementation called kubevela, and then tie everything to OpenTelemetry. So bear with me. We're going to touch about each and every CNCF projects here in the next 20 minutes. About the background of cross-plane. So think about Kubernetes, right? Kubernetes is a well-known for container orchestration and management. But Kubernetes also has the first-class API-driven, where you can actually manage your not only the containers, but hyperscale resources. Talk about AWS services, GCP services, right? So basically, we're trying to have a cross-plane, the CNCF project, as a control plane. That control plane is managing all your resources, databases, schema management, your CI/CD pipelines, and stuff like that. So that's the kind of the gist of this particular diagram. What are we trying to do? What are we trying to achieve here? We are trying to achieve a centralized development environment. We are trying to have a security baked in. So when you deploy the cloud applications, you are taking away the concerns from application teams from the security, and you're baking those into the platform itself. What's a common example? Let's say you have a CI/CD pipeline. You have going to the build, tests, and deploy phase. Can you bake in the FOSSA scan as an example in the CI pipeline? Is it breaking your license? Can you bake in your static code analysis on the pipeline itself? So you're taking away those security concerns from developers to the platform team. Can you have your CI pipeline be done programmatically? So for example, applications teams today write Docker files. Can you move that Docker files in a programmable way? There's an open source project called Dagger. Dagger has the programmable CI/CD pipeline. So you can use those, you can have a hardened base image, and then build top of those images your application images. So that way, then you can do a cryptographic signature of those images. You can then have in the time for deployment, you can have your Kubernetes admission controllers, which can check if this database, if this image that you built 6 months ago, if it has a CVE, you can have your admission controller reject that because the teams have to still run the CV fixes. So you're taking away those applications concerns and building in the platform itself. Why you have to do that? Because the reason is that every team picks their own tooling and technology, which works fine at the small scale. But when you are an enterprise company, you don't have the luxury, because those best practices from one team do not move to the team. On top of that, you don't have centralized operations. So for example, I don't know about you, but I've been on the bridges in my companies where there has been 100 people on the call for the incident, and someone will ask this question: was there a deployment 20 minutes ago? Because we don't know, because there's no set of standardized dashboards and metrics to take a look at what happened, what caused the incident, right? So the behavior that I'm trying to say is that when you want to build your enterprise scale software, you have to have the operations mindset, and the IDP brings that in the center foremost from an efficiency point of view. I will touch about these common themes for building the observability for the cloud developer applications team. So we talk about the auto instrumentation. We'll talk about logs, metrics, trace, and correlation. We'll talk about the network observability, CI/CD observability, and synthetic transactions. The way all your application team needs all these different components of observability. We'll touch upon all those in the context of IDP. Before that, let me give you the kind of a blueprint of how a commonly deployed architecture of OTel collectors looks like in this case. So on the left side, starting on the left side, you have basically this is a fleet of collectors, right? So each collector is doing their own responsibility, separation of concern. So on the left side, you have a collector that's actually running as a daemon set on Kubernetes node. It is getting all the logs, traces, and metrics. But before it is doing that, the collector is sending the logs it's running as a daemon set, so it is sending its data to the node itself, the Kubernetes node itself. And then on the agent, we have the scraper. So basically, if your application is sending the Prometheus metrics, you can have a Prometheus receiver on this collector, which can scrape those data points. Also, if their service has the Istio, the service mesh, you can also instrument your observability for getting the network traffic. So think about this: you're running you have a sidecar envoy proxy, which has all the data in terms of where is the TLS termination happening. It can get the data from the service itself and pass on, tag along with, and to its main container and send the data. Now, once the collector receives the traffic, we actually send it to the centralized collector, the gateway collector. Now, the gateway collector has a fan-out mechanism. The gateway collector then sends the data to other collectors. So think about this: if you want to run the tail sampling, the tail sampling has the feature where all the spans of a trace should go to the one collector, because at the end, the tail sampler has to make a decision that should I export this traces to the backend. The backend could be your Grafana, could be Honeycomb, could be any vendor of your vendor choice. But then the decision has to happen at the tail sampling, and for which all the spans of a trace should end up with the same pod of the collector to make its decision. Then you can also have a span matrix. So the span matrix basically will derive the metrics from the spans, right? And then if you want to generate a service graph, you want to have your SLO, SLI based on how each of your applications are interacting. You can generate a service graph because the same load balancing exporter can send the traces to a particular service ID. So it will collect all the spans from that service and generate a graph based around your service topology. We'll see some of the examples in the following screenshots but this architecture is basically showcasing you both from the logs, metrics, and traces. Now you also on the right hand, on the bottom right hand corner, you have other collectors. So for example, if you are running Kafka, Pulsar, any database like Yugabyte or Postgres, you also want to instrument those managed services as well. So you can have an OTel collector pointing to those Prometheus scrape endpoints and have those collectors scrape those. And then you can have a better correlation because the same collectors are also going to the main gateway collector. So not only are you able to trace your application observability, but also from the infrastructure point of observability. And you can combine those two together to give you holistic view. I'll talk about, so we talked about just how we ingest to the OTel collectors. Let me talk about the best practices I have seen in terms of scaling and improving telemetry. The first point being here is the span filtering. So the cost of ingestion to your backend depends on how at OTel collector processor layer you want to handle it. So if you want to enrich your logs with the trace ID, with the more context, here's at the OTel collector processor, you can attach those metadata. You can have the OpenTelemetry transform language OTTL processors that can further enrich the data. And you can also drop your noisy data. So the second point was the enriched signal with context. So you can add resource attributes. So OpenTelemetry has a good semantic conventions around which label you want to attach to it. So if you're running in a different cloud provider or if in a different region, you can add those labels to the in the processor stage. Now most of the applications today have the logging capabilities, right? And if you want to do the OpenTelemetry, OTel has something called log bridge. So you can have that instrumentation and then have the same semantic conventions that can attach the logs with those labels and send the data to the OTel collector. The reason I wanted to mention about the correlation between the traces and metrics is that if there's a spike in the metric and you want to see what caused that spike, so you should have a relation between the trace and metrics and logs. The mindset of also the operations engineer would be like, don't show me the logs that are 5xx errors. Show me what service it cost, where it came from. So you're attaching all those metadata labels in the OTel processor, which is giving you the whole context. Managing observability is around how you want to treat your telemetry. So like for example, when we write our infrastructure, like AWS services, either we use Terraform or Crossplane or something like that. So in my mind, the same goes with the observability too. So you have to treat your telemetry as a code. So you can version your schema. You can also look at your instrumentation score, like how bad that telemetry is when it's making those changes. So those are all in the source control way. That's how the key point for this slide is. You also want to provide, the platform team should also provide the pre-configured attributes for OTel collector configuration, default exporters, and sampling rules. That's the best practice so that your service teams don't have to reinvent the wheel. Right. Now, in this following slide, these are like the screenshots for what I was been mentioning about in terms of correlating signal. In this slide, you're seeing the network observability. On the first hand, so I was mentioning about the Istio, the service mesh. The service mesh has this provider, external provider, that can send the traces to OpenTelemetry collector. That's how you can now understand from the service point of view, its Envoy proxy is how it's able to handle those traces. So in this screen, you're seeing the logs and traces correlation from the network point of view because the Envoy is capturing those traces on behalf of the service itself. This is a feature for exemplars. So metrics to traces correlation. On the left side, you're seeing this time series graph. And if you want to understand any spike here, and you want to click on that metric point, it can actually go to the traces and can show you the whole waterfall, what caused that spike to happen. Right? Service graph. I was mentioning about the span metrics and the service node graph. This is how you get that view if you're able to correlate all your signals in one gateway collector. Now, so we talked about the collector. How do you do the operations around the collector itself, right? So these are some of bunch of metrics in terms of your receivers, exporters, and processors. The key takeaway is that you have to monitor all these signals to understand when you have to scale your OTel collector to meet either the latency that either your tail sampling processor or your load balance exporter has been experiencing. So for example, in this case, one of the metrics is about the latency. So it basically measures how long it takes for a sampling decision for a trace before it becomes eligible for evaluation. So if you're seeing the high latency, that means you have to increase the concurrency or the number of replicas of the OTel collector. By doing that, you also have to make sure that OTel collector, when you're scaling, it's only scraping those jobs that it's responsible for. Otherwise, it will duplicate time series data. Few things about from the deployment point of view. So Argo rollouts has this baked in with OpenTelemetry. So if you're doing the canary deployment, you can have your applications instrument go the same auto collector deployment and send the signals. So you can now make correlation between, is my new version of app, is it stable than the previous app or not? You can make your decisions around that part, and then either you can abort the deployment or you can continue with your deployment. So basically showcasing the integration between the OpenTelemetry and the Argo rollouts here. About CI/CD observability. So we use this framework called Temporal. Temporal workflow is basically, it automatically captures state at every step. And in the event of fail, it can pick up exactly where it left off. So basically, it is, you are seeing on the left side the CI pipeline. And then when the CI pipeline is done from the GitHub commit, it's going to the same trace is going to the CD workflow, and then it is doing all the validation and the hydrator. So basically here, the point of context is that the applications team are writing the code from an expressing point of view of what they need. So if they need, if my application needs a load balancer, or if my application needs a database or a messaging system, the infrastructure team will then take those concerns and then using the kubevela, will be able to express into Kubernetes objects. Now, the main takeaway is that the OpenTelemetry can integrate with each of those steps in the temporal workflow, and then attach all the spans from each of the stages into one waterfall model. And that's what you get here in terms of the dashboard. So basically what you're seeing is that on the left side, you have the traces for both from the CI and CD together across all your environments. And you can be able to find out where in your step, which is a bottleneck, is your bottleneck is in the queue for your deployments, or is it in the build phase, as an example. Synthetic and monitoring tests. So this is where K6 is also another open source project. If you want to integrate with OpenTelemetry to do a synthetic transaction, so if I want to understand if I'm doing the OTA deployment to a vehicle, if I'm touching 100 services across the line, and I want to test it in a way that I can catch the problem before the end user catches it. So this is where the OpenTelemetry along with the K6 can give you the whole end-to-end workflow, and you can use this workflow with your own deployment workflow, like in the previous screen, the Argo rollouts, to make sure that your deployment that you're doing is good enough, it's not causing any regression. The last slide here is about dashboards and alerts as a code. So the same way we are treating all telemetry as a code, I want to emphasize that all the dashboards and code alerts should also be treated as infra as a code. So for example, you can have the same cross-plane that we talked about, that's underlying your infrastructure, can also, for your choice of tooling, whether it's a Grafana, as an example, open source, you can have a provider for Grafana and then have it use it for your alerts and management of the dashboards. That way you have a consistent way of dashboards for all the service teams. No one is having their own silo dashboards, and it's also a version control in a way that if I am a SRE engineer and I'm on call, but I don't own that service, I can still be able to make sense of it because of the cementing conventions and also the same metric registry, as an example. That's all I had. This is the feedback code, so I would appreciate if you can have feedback for the session, and I can take any questions you may have on this time. Yes.
Excuse me, there's a microphone in the middle. If you have a Q&A question, just walk over to the microphone.
So my question was around the sampling strategy. So all spans firm-wide are being sent to a centralized fleet of OpenTelemetry collectors, which then make the sampling decision. And if that's the correct understanding, what is sort of the volume at which these spans are coming in per second or per day?
I can't talk about the specific numbers of the industry I work for, but we, on a general figure, we handle close to, let's say, 3.5 million spans a minute. I'm talking about close to 100 services as an example. And the centralized gateway collector is not just one pod, it has a multiple replicas, and it has a built-in, we use this framework called Kubernetes Event Autoscaler, KEDA, Kubernetes Event Auto Discovery. So it basically not only based on your CPU and memory consumption, you can define your own metrics. So for example, I was talking about some of the metrics that we track in the tail sampling and the load balancing exporter. You can use those metrics and scale your OTel collectors based on that, right? So basically create a custom metric, not only based on your CPU and memory, to scale those collectors. You also have to make sure that those collectors are not duplicating its job. I mean, you can shard your applications so that only those collectors are responsible for scraping those, as an example, right? So this is like a central heartbeat in that case. Yes.
Very quick follow-up.
Yes.
How do you handle back pressure?
Yeah. It didn't say that this diagram, so we have Kafka. So you can have the OTel exporters talk to Kafka, and then it can replay the data if there's a back pressure. Or let's say we are doing the maintenance of OTel collectors, upgrades, right? So it's a rolling upgrade strategy, but you can have still the data in the collectors, in the Kafka queue, that can replay the data when the collectors are back online.
Yeah. All right. Thank you so much.
Yes. I think we are up the time, but do you have one more question? Okay, go ahead. Yeah.
Hello. Thank you for the presentation, by the way. You had a slide for CI/CD collecting spans and metrics.
Yes.
No, I think one more maybe. Yeah, so that one. Can you just explain what tools did you use to collect these? Are you collecting these from GitHub Actions? And
Yeah.
Okay.
Yeah, sure. So basically, we use this tool called Dagger, dagger.io. It's an open source tool. Dagger is basically, it builds your CI pipelines programmatically. So when a developer push a commit, from that point of time, we start through the GitHub Actions, the webhook APIs. And that's integrated with the OpenTelemetry instrumentation. We use Golang or Java, doesn't matter which language, because it's the auto instrumentation provider for it. So from that point of time, we start the parent span, the parent span. And then with the context propagation, we're able to, push the same trace ID to each and every request. And then on the CD side, we use something called temporal, and the other open source temporal workflow. So it has the concept of activities. So you can fan out each of those build phases. So I talked about, for example, the open application model. If your application needs, let's say, a database, it will make sure that your database spans also in conjunction with your CD pipeline. So it's basically tracing end to end. Did I answer the question?
Yes, thank you.
I will be in the hallway if you guys have any more follow-up questions. Thank you.